So today we'll be starting quadrilaterals, that is chapter number 8. And you are already aware what quadrilaterals are. Quadrilaterals are four-sided figures. The sum of angles of a quadrilateral will be 360 because actually when you talk about quadrilaterals, a quadrilateral is made up of four sides. It has four angles as well. So here, when I'm having a quadrilateral, let's name this quadrilateral ABCD. It is actually made up of two triangles. And we know that sum of angles of a triangle is 180. So this actually consists of two triangles. So the first property of any quadrilateral is that it is made up of four sides and the sum of angles of the quadrilateral is 360. So definition of a quadrilateral is a four-sided figure in which the sum of angles will add up to 360 degrees. Now, there are different types of quadrilaterals which you have learned in the previous years. The first is square, right? A square has all sides equal, diagonals intersect at 90. Then we have a rectangle in which only the opposite sides are equal and parallel, diagonals are equal. And we have a rhombus. A rhombus is a figure in which the angles are not 90. The diagonals intersect each other at 90, yes. Diagonals are not equal like a square. So the basic difference between a square and a rhombus is that in a square, all sides are equal and angles are 90, but in a rhombus, all the angles that you see are not 90 degrees, okay? And this may not be 90. But all the sides are equal, yes. So that's a rhombus. And parallelogram, of course, you are aware, this is a parallelogram. Only the opposite sides are equal and parallel. And of course, the diagonals are unequal and they also bisect each other. A trapezium is a four-sided figure in which one pair of opposite side is parallel. One pair of opposite, only one pair. If both are parallel, then it becomes a parallelogram. And a kite is a figure in which two pairs of adjacent sides are equal. So these two sides are equal and these two sides are equal. In this also, the diagonals are going to intersect each other at 90. So these are some basic properties of quadrilateral, which you have done in class 8 as well. So I'm not going so much into the details of the properties of each of this. Now here you have a theorem here, diagonal of a parallelogram divides it into two congruent triangles. This theorem is important and can be asked for proof. So you can go through this. It's pretty simple. We know that if this is a parallelogram, then the opposite sides are parallel. If opposite sides are parallel, then these are alternate angles. So you have two pairs of alternate angles and AC is common. So triangles are going to be congruent by ASA. So that is the first theorem that has to be done. Of course, there are many theorems, but the proof is only required for the first one, that is quadrilateral. A parallelogram divides. In a parallelogram, the diagonal divides it into two congruent triangles, right? So with the help of the properties and the congruency conditions that you have learned, you will be able to solve the first exercise. The first exercise is simply based on the properties of the quadrilateral, which you have done in class 8. And it is also based on the congruency, which you have learned this year. So here we have the first exercise before us. Show that if the diagonals of a parallelogram are equal, then it is a rectangle. Show that if diagonals of a rectangle are equal, okay, show that if diagonals of a parallelogram are equal, then it's a rectangle. So let's make the figure here. This is question number 1. Let's name this figure ABCD, and what is given to us is that ABCD is a parallelogram. ABCD is a parallelogram, and what we need to prove is that this figure is a rectangle. ABCD is a rectangle. And also, if you read the question carefully, it is given diagonals of the parallelogram are equal. So it is also given to me that AC equal to BD. AC and BD are equal. So how will I prove this? How will I prove this? I am going to make use of congruency. So what am I going to do? I'm going to select triangle DAB, right? This triangle DAB and this triangle CBA, and prove them congruent. DAB and CBA, I'm going to prove congruent. So if I look at DAB and CBA, it is given it's a parallelogram. So if it's a parallelogram, DA equal to CB. Opposite sides of a parallelogram are equal. So we know that DA and CB are equal. AB and AB are common. AB equal to AB common, right? Whether you look at DAB or you take triangle CBA, you find that AB is common for both these triangles. And the third condition is already given to us, that the diagonals are equal. This condition was already given to us. So we can say that the length of DB equal to AC, given. So we know that if three conditions are there, triangles are congruent. So, so triangle DAB is congruent to triangle CBA. And which condition are we using here, SSS? Because we have side, 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 all three sides. If the triangles are congruent, now angle A equal to angle B, CPCT. Angle A and B are going to be equal, CPCT. Now we know that this is a parallelogram, so co-interior angles will end up to 180. These are co-interior angles, A and B are co-interior angles. They will add up to 180, and we already said that they are equal, and therefore we can say that A and B are going to be 90 each. If they are going to be 90, this is definitely a rectangle, because we know that it's already a parallelogram. And now we have proved that the angle is 90. In a parallelogram, is one angle is 90. All angles are 90. Therefore, this figure is a rectangle, right? So this is our answer number 1. And we go on to the second question. The second question says that show that diagonals of a square are equal and bisect each other at right angles. Show that diagonals of square are equal and bisect each other at right angles. So it is already given to us that there is a square. So let's draw a square. So this is a square. Show that diagonals are equal and bisect each other at right angles. This is our question. So ABCD is a square. Given ABCD is a square, we have to prove that diagonals are equal and bisect each other. So we have to prove AC equal to BD. We have to prove that OA equal to OC and OB equal to OD, right? And we also have to prove that diagonals bisect each other at right angles. That means we need to prove that these angles are 90. So we need to prove that AC and BD intersect at 90 degrees. So any of these angles we need to prove 90. So there are three parts to the question. The first part, we need to prove the diagonals equal. And to prove the first part, I'm going to use congruency. I'm going to take the triangles DAB and triangle CBA and prove them congruent. DAB and CBA, and prove these two triangles congruent. So we know that sides of square are equal. So DA equal to CB. AB equal to AB common. This is equal because sides of square are equal. So DA and CB are equal. AB is common. And it is already given square. So angle A and angle B are 90. Angle A and angle B are 90. So we've got three conditions. Side, angle, side. So triangles are congruent by SAS. Side, angle, side, right? So triangles are congruent by SAS. So here when the triangles DAB and triangle CBA are congruent, then we get the first part DB equal to AC. Okay, CPCT, corresponding parts of congruent triangles are equal. So first part is over. To prove the second part, now we have to prove OA equal to OC and OB equal to OD. We are going to take these two triangles AOB and COD. So take triangle AOB and triangle COD now. I want to prove AOB and COD congruent. So what I'll do is I'll number these angles. Angle 1 and 2. These are alternate angles. These are alternate angles, right? Angle 3 and 4 are also alternate angles. And AB and CD are equal to each other because sides of square are equal. So we've got AOB and COD congruent by ASA, right? So 1 and 2 equal, 3 and 4 are equal because they are alternate angles. AB is equal to CD. Again, reason sides of square are equal. So AB and CD are equal. So we say triangle AOB is congruent to triangle COD by ASA. Triangles are congruent by ASA, angle side angle. And therefore, we can say OA equal to OC and OB is equal to OD by CPCT. OA equal to OC and OB equal to OD CPCT. Now we have to prove that they are 90 degrees, and for that, what I'm going to do is take a different pair of triangles, that is, third part, I'm going to take triangle AOB, this triangle AOB and triangle COB. I'm going to take triangle AOB and triangle COB and prove them congruent. So how am I going to get that? OA and OC we have already proved equal just now. OA equal to OC proved. In the second part, we have already proved just now. OA equal to OC. We are making use of that. OB equal to OB common. OB is common. OB is OB common. And here, third condition, AB is equal to BC because it is given that they are sides of a square. Sides of a square are equal. So we've got triangle AOB and triangle COB congruent by SSS. We've got triangle AOB and triangle COB congruent by SSS. And if the triangles are congruent, then I can say these two angles are equal by CPCT. So let me say these are 5 and 6. They are equal by CPCT. Now 5 plus 6 is 180 because it's a linear pair, right? In lines and angles we did. If angles are on a line, their total will be 180, right? So 5 plus 6 is 180. Now 5 and 6 are equal and they are 180. So we can say that 5 and 6 are 90 each. And therefore we can say that AC and BD intersect at 90, or diagonals of square bisect each other at 90. So AC and BD intersect at 90 degrees. So this will be answer number 2, which is in 3 parts. First we prove diagonals equal, then we prove diagonals bisect each other, and then now we have proved that diagonals intersect each other at 90. Question number 3, diagonal AC. Figure is already given to us. Diagonal AC bisects angle A. Diagonal AC bisects angle A. That means already it is given to you that 1 and 2 are equal. Show that it bisects C. That means I have to prove that angle 3 equal to 4, and I also have to prove that ABCD is a rhombus. So diagram is already given to us. We will number these angles 1 and 2, 3 and 4. Now what is given to us that 1 and 2 are equal, and it is also given that it's a parallelogram. So if it is a parallelogram, angle 1 will be equal to 4 and 2 will be equal to 3, right? Because they are alternate angles. Alternate angles are equal, so 1 will be equal to 4, 2 equal to 3. Now 1 and 2 are already given equal, 1 equal to 2 given. So LHS is equal, no? 1 and 2, LHS of 1 and 2 are equal. So therefore RHS will be equal. So first part, we'll get 3 equal to 4. 3 equal to 4 means AC bisects angle C. So we've got this 3 equal to 4 first part. So 1 is 4, 2 is 3 because they are alternate angles, but 1 and 2 themselves are equal, so 3 equal to 4. So AC bisects angle C, we got the first part. Second part, we have to prove it's a rhombus. If I want to prove it is a rhombus, then I have to prove that adjacent sides are equal, because since it's a parallelogram, already the opposite sides are given equal. Already the opposite sides are equal. Now I just need to prove adjacent sides are equal, because if I want to prove that any figure is a rhombus, all I need to do is prove that all sides are equal. So how to prove all sides equal? I can take triangle ABC and triangle ADC and prove them congruent. I will take ABC and ADC and prove them congruent. So angle 1 and 2 are equal because that was already given to us. 3 and 4 just now we proved. 3 and 4 proved. AC is equal to AC common. So 1 and 2 are equal, 3 and 4 are equal. 1 and 2 was already given to us, 3 and 4 we have proved, and AC is common. So we can say that triangle ABC is congruent to triangle ADC by ASA. And if the triangles are congruent, therefore I can say AB equal to AD CPCT. And we know that if adjacent sides are equal, then in a parallelogram, if adjacent sides are equal, all sides are equal. So therefore, we can say ABCD is a rhombus. So that's the answer to question number 3. Then we go to question number 4. So question number 4, the diagram is not given, we need to make it. What is given to us in the question is ABCD is a rectangle. ABCD is a rectangle. So ABCD is a rectangle. AC bisects angle A and C. So this is getting bisected. That means angle 1 equal to 2 and angle 3 equal to 4. AC bisects angle A and C both. So what is given to us is 1, 2 and 3, 4 are equal. Now the question is show that it is a square and BD bisects B and D. So let's tackle the first part. We need to prove that it is a square. It is already given rectangle. That means all angles are already given 90. It is given rectangle, that means opposite sides are already equal. So we need to just prove adjacent sides are equal. So we are going to take triangle ABC and triangle ADC and prove them congruent. So 1 and 2 are equal, 3 and 4 are equal, already given to us. This was already given to us, and AC is AC common. So we have one angle here, and side in between. So triangles are congruent by ASA. Triangles are congruent by ASA, and if they are congruent, then AB equal to AD CPCT. If adjacent sides are equal, in a rectangle, then all sides are equal. Therefore, we can say the first part ABCD is a square. So from here, we can say ABCD is a square. We don't have to prove 90 because it's already given it's a rectangle. So this is our first part. Now we need to prove that BD bisects B and D. Okay, so let's redraw the figure so that there is no confusion. Now we have to prove that BD bisects angle B and D. That means I need to prove in this figure these angles BD bisects angle B and D. These two angles are equal and these two angles are equal. I have to prove. Now already we have proved that this is a square, so that can be used here. That can be used here. So if I represent this by ABCD, these angles that I have taken, I need to prove that A equal to B and C equal to D. I have already proved that this figure is a square. So what I need to do is just prove the triangles ABD and triangle CBD congruent. I'm going to take ABD and CBD and prove them congruent. So how will I do that? AB is equal to BC. Sides of square are equal. We have already proved it's a square. So this side and this side are equal. AD and CD are equal. Again, sides of square are equal. This is a square. So sides of square are equal. So AB equal to BC. DA is equal to DC. These two sides are equal and BD equal to BD common. BD equal to BD common. So triangles are congruent by SSS. And if the triangles are congruent, then these angles are going to be equal. Angle A is equal to angle B and angle C is equal to angle D. And therefore we get BD bisects angle B and D. Right? So both the parts we have done. Moving on to question number 5. Question number 5, the first part, prove that triangle APD and triangle CQB are congruent. It is given that it is a parallelogram. So how will I prove this congruent? If I look at this triangle, AD and BC are equal. AD equal to BC because opposite sides of parallelogram are equal. And here it is given that DP is equal to BQ. This part and this part are equal. DP is equal to BQ given. So AB, this opposite sides are equal. AD equal to BC. DP equal to BQ. This is given and it's a parallelogram. So we know that this angle and this angle will be equal. 1 and 2 are equal alternate angles. So if I name this angle ADP as 1, and CBQ as 2, angle 1 equal to 2 alternate angles. Right? Alternate angles are equal. So triangle are congruent by which condition? SAS. Triangle APD is congruent to triangle CQB by SAS congruency. SAS. Therefore, AP equal to CQ, CPCT. So the first part you will prove, second part is CPCT. For the third part, triangle AQB and triangle CPD. If I take these two triangles now, what are the conditions? I will use 3 and 4 now. So look at the triangles that we are taking now. It is AQB, that is this here, AQB, and CPD. So here now this side and this side are equal. So for AQB, I will get AB equal to CD. That's one condition. Opposite sides. Here also we'll make use of this condition that BQ equal to DP. That is already given. BQ equal to DP already given. And now angle 4 equal to angle 3 alternate angles. So it is almost similar to the first part. Only here we have different set of angles 3 and 4. Otherwise, DP and BQ was already used first also, now also we are using. And of course, the other pair of opposite sides, we will use AB equal to CD. So triangles again are going to be congruent. We have got two sides and one angle. So triangles are congruent by SAS. Therefore, this is going to come by CPCT. So from 2 and from 4, we can say it's a parallelogram. From 2 and 4, we have already proved. Second, AP equal to CQ. We have already proved AQ equal to CP. So from 2 and 4, we can say that APCQ is a parallelogram. Why? Because if opposite sides are equal, if a pair AP equal to CQ, that's one pair, and the second pair AQ equal to CP, both pair of opposite sides are equal, then that figure is a parallelogram. So that's question number 5. Question number 6, the figure is again given. It's a parallelogram. We have to prove the triangles congruent. So this is also easy. Here, first condition, AB is equal to CD. Opposite sides of parallelogram are equal. Second condition, we can say that this is 90 degrees. Angle APB is equal to angle CQD because they are 90. This is 90, this is 90. And we know that angle 1 equal to angle 2, alternate angles. Alternate angles. Why? Because this is a parallelogram. If it's a parallelogram, then opposite sides are parallel and equal. So if it is parallel, then these are alternate. This is parallel and this is the transversal. So 1 and 2 are equal. So we can say the triangles are congruent because we have two angles on one side. Triangles are congruent by angle. This is angle here, angle, angle side. Angle, angle side. It is not ASI, it is AAS, angle, angle side. Therefore, AP equal to CQ, CPCT. Now we come to the seventh question. That's an important question. Here, ABCD is a trapezium. AB and CD are parallel lines. AD and BC are equal. There are 4 parts. And this part is important. So let me solve it on the screen here. So it is given to us that this is a trapezium ABCD. And here ABCD is a trapezium, AB and CD are parallel. The first part we have to prove angle A is equal to angle B. And here in the hint of the textbook, they have given that we need to draw a line CE parallel to AD and extend AB. But this hint obviously will not be given in the exam. The hint is draw CE parallel to AD. We are drawing this line parallel to this and we are extending AB, right? So this is going to be our construction. Draw CE parallel to AD. Okay, this is parallel. This is already parallel. So this whole figure becomes a parallelogram. This whole figure becomes a parallelogram. Now, first part, we have to prove that angle A equal to B. So to prove A equal to B, I'm just numbering this so that it becomes easy for us. So as I said, by construction, CE is parallel to AD and AB was already parallel to CD because it's given that this is a trapezium. If two pairs of opposite sides are parallel, then this whole figure becomes a parallelogram. ADCE becomes a parallelogram. This figure, ADCE, parallelogram. If it's a parallelogram, we know that co-interior angles add up to 180. This is parallelogram, so these are parallel lines. So angle 1 and 4 will give you 180. Now we have numbered angle B here inside 2 and outside 3. So 2 plus 3 is 180 because linear pair. This is because co-interior angles. Because these are parallel lines, it's a parallelogram. So these are co-interior angles which add up to 180. 2 and 3 form a linear pair. So 1 plus 4 is equal to 2 plus 3. Two things equal to the same thing are equal to each other. So 1 plus 4 is equal to 2 plus 3. Now, if you look at 3 and 4, they are equal because in the question it is given that AD equal to BC. AD and BC are equal and it's a parallelogram. So AD equal to CE. This is given. This is because this is a parallelogram. So opposite sides of a parallelogram are equal. So from this AD is common, therefore BC equal to CE. If two sides are equal in a triangle, last year you have done this theorem. And this year also you have done that in a triangle, if there is a triangle with two sides equal, that is isosceles triangle, then the angles opposite to them will be equal. So 3 will be equal to 4. So if BC and CE are equal, then obviously 3 and 4 are equal. So I can cancel 3, 4. I will get 1 equal to 2. And the first part of this question is proved, which means that angle A and B are equal. Second part, we have to prove that angle C equal to angle D. We have to prove that this angle and this angle C and D are equal. C and D equal has to be proved by using co-interior angles. Now, angle 1 plus D is 180 because AB and CD are parallel. So, co-interior angles add up to 180. Whenever you have two parallel lines, the co-interior angles add up to 180. 1 plus D is 180. 2 plus C is also 180. Both because they are co-interior angles. Okay, they are co-interior angles. sum of co-interior angles add up to 180. So AB and CD are parallel lines, right? It's given to us. So these are co-interior, consecutive interior angles. Therefore, I can say that 1 plus D is equal to 2 plus C, and we have already proved that 1 is equal to 2. So 1 and 2 gets cancelled, so we get D equal to C. So we've got the second part, that angle D and C of this trapezium ABCD are equal. This is our first part, this is our second part. Now, we have to prove that triangle ABC is congruent to triangle BAD. Triangle ABC is to be proved congruent to triangle BAD. So look at the triangles very easily. We can say in triangle ABC and BAD, AB is common. Whether you take ABC or BAD, AB is common. We have already proved angle 1 equal to 2 in the first part. Proved in 1. 1 equal to 2. Proved. AD is equal to BC was already given to us. BC and AD are equal, given. So we have 3 conditions with us in triangle ABC. Let's take this 2 and 1 because in triangle ABC we have marked as 2. Okay. So AB and AB are common for triangle ABC and triangle BAD. AB is common. Angle 2 and 1 are equal. That we have already proved in the first part. And BC is equal to AD. BC equal to AD. That's also given to us. So triangles are congruent by which condition? Look at this side, angle side, SAS. The triangles are congruent by SAS, and therefore the diagonal AC and BD will be equal by CPC. Therefore, the diagonal AC and BD will be equal by CPC. So, this is the first exercise. In the second exercise, we will be doing questions based on midpoint theorem and converse of midpoint theorem.